Okay, welcome back everyone. So this is the last talk on this track, and it's by Leah Wasser about pyOpenSci.
Thank you, Brigitte. Hi, everyone. I am really excited to be here today. Thank you for hanging around for the last talk of the day. I know there's like lightning talks and other fun things going on, so thank you for being here. I am so excited to talk to you about the work we've been doing around community. So Eric Ma kind of opened this up with open source and the work that he's doing in the corporate world. And now I'm going to talk a little bit more about the nonprofit world and how we can work as a community together to solve problems. So my name is Leah, and I am the executive director and founder of pyOpenSci. And pyOpenSci seeks to empower scientists to tackle the world's greatest challenges. And we do that through both helping them build better software and also empowering them with the skills that they need to make their science more open and collaborative. pyOpenSci has three core pillars. So we have an open peer review process. We work with partners and leverage community partners wherever we can. And then we also do education and training, like a tutorial that I ran yesterday that we ran on packaging, which I see some familiar faces in this room, people that were there. Now, a little bit about me. I love tackling the most challenging topics and making them more accessible to beginners. And that includes packaging. And I'm having a lot of fun. And yes, fun and packaging can go together in the same sentence. I'm having a lot of fun with that. Just seeing the delight in people's eyes when they figure out how to create a Python package is a truly rewarding experience. I also am an expert in imposter syndrome, and I say that because I have 2 design degrees, but then I decided to get a PhD in ecology, and I will never forget reading my first scientific paper and almost crying because I didn't understand most of the words. Finally, I'm a maintainer of a package called Stravalib, and this is my dog. She is a foster fail. Her name is Juno, and she's a fail because I tried to foster her, and I fell in love with her, and I had to adopt her, and I love her to death now. So that's her story. So today I want to talk about 4 themes. I want to talk about partnership, connection, usability, and inclusion. And I want to talk about those in the context of solving our most challenging problems. When I first started using Python, about 10 years ago, I had been teaching R, and I switched to Python, and I just wanted to install spatial packages, and it was really hard, really, really hard. I might have cried a little bit then, too. And thank goodness, Felipe Fernandez from Conda Forge made this meme. If you've seen it, it's his, and he's very shy about the fact that he's really good at making memes. Thank goodness for Felipe, because he helped me figure this out. He helped me understand Conda and Conda Forge and pip and conflicts and all of that stuff. And I got through it, and we were able to successfully start teaching Python to students, which was sweet. But I have to tell you that it's hard to find the right package. This is a maintainer summit, but as a user, sometimes finding the right package to teach or to use is really hard. So I was really surprised I was looking for spatial packages, and there were so many options. So I went to Pangeo because I loved Xarray, and they had this great list of vetted tools that were like affiliated with Xarray. And I started looking at them, and some were maintained and some weren't maintained, and the docs were kind of good on some and maybe less good on others. And I was like, oh, this is a little harder than it should be. So then, once we found the right tools, I noticed that a lot of the tools were single maintainer tools, a common thing in open source. But I thought about, from an open science perspective, what happens when that maintainer needs to step down and people are relying on that tool for their open workflows? Now, finally, I spent a lot of time getting to know maintainers in this ecosystem because I was trying to figure out what the tools did. The docs, my students were struggling with the docs. They couldn't just read the docs, know how to use the tool, and have that win of like, yes, I want to process my data. So this was a challenge, and I asked myself a few questions. What if finding the right package was easier? What if community vetted tools were maintained, but also you could go to one place to find them, so you're not searching all over the internet for tools. And what if we could help maintainers step down in a graceful way when they need to do that, or at least communicate with the community that, hey, this tool is no longer being maintained, so maybe you might want to use this other tool now. And then finally, what if docs were more beginner-friendly? So in 2017, I started to think about what would it look like to build on top of the amazing work that the pyOpenSci community has done. And in 2018, I started holding community meetings to informally talk about what would a constructive, open peer review process of software look like. We wanted scientists to have a place to find vetted software, but we also wanted maintainers to have a place to not only have a package reviewed, but ask questions about packaging, to talk to each other, and to solve common pain points together. We wanted to support the tools that are single maintainer tools as well. So as a maintainer, if you need to step down, maybe we can find a new maintainer for that tool. If we have to sunset the package, that's fine too. We just need to communicate that with the community. And finally, we knew that it was really important that maintainers get academic credit for the work that you're doing. You're supporting science, but there's not enough credit involved with that support and that critical, hard work. Diversity. We know that diverse voices can lend themselves to better reviews. In some cases, diversity might mean allowing someone that is maybe newer to peer review and maybe a little bit newer, not an expert in Python packaging, to review a tool for usability. Can I use it? Can I install it? Do I understand the docs? Are there quick starts for me to get going? Why aren't those voices a part of our peer review process? But also diversity requires carving out space so that we can make sure that more people get involved. So that takes form in the shape of a mentorship program. By teaming new reviewers up who might not otherwise feel confident enough to get involved, now we're empowering them to be a part of the peer review process. And often, those reviewers, they might turn into editors. And what's really cool about that is now you've got people that might not have already been involved in the ecosystem in leadership roles in the organization. So that's pretty awesome. So this is what our peer review process looks like. So first, you might submit your package. We have a set of community-derived peer review checks that are the basic things that a Python package should have. So that's stuff like docs, tests, is there CI, is there quick starts for our tutorials to help someone get going? Is the README clear in terms of what the package does? That's run by our editor-in-chief, and then the review itself is 2 or more reviewers that will go over that package, and there'll be a constructive review process with the goal of making the package better. That constructive review process might take the form of both that review that gets submitted to us, but also pull requests and also issues opens. And where we can, we want to help the maintainer improve the project, not just throw all that work back on the maintainer. Once the package is accepted, then it's part of our pyOpenSci ecosystem, and it becomes, and then we will provide more visibility for that tool to the community. But that's not the end of the story. We also care about long-term maintenance. So we're going to be checking in on that package to see if it's maintained over time, and then have that discussion with the author if a package becomes unmaintained. We also are leveraging partnerships. So what that looks like is we're working with domain-specific communities like AstroPy. In a partnership example, we might have a package that comes into review that also wants to become AstroPy affiliated. And AstroPy has actually run a peer review process. They're one of the more mature communities in the ecosystem, and they had their own peer review process. So we decided to partner so that they could focus on the work they're doing in that community, and then we could work together and they could leverage our peer review process. So we add this additional level of checks, which are the AstroPy standards for being community affiliated. And through our peer review process, now you can become accepted by pyOpenSci, community vetted, and also AstroPy affiliated. The last piece of this partnership is JOSS, the Journal of Open Source Software. If you remember earlier, I mentioned the importance of academic credit for your work. So we partner with JOSS, which means that through the same review process where you can become community affiliated, pyOpenSci accepted, you can also get a JOSS publication. And that is not another review. They accept our end-to-end review process as theirs. They will look at your paper. It's a fast track. It normally takes a couple of weeks. And now you've got 3 pieces. You're pyOpenSci accepted. You're part of the AstroPy affiliated ecosystem if you are an AstroPy related project, and you are Journal of Open Source Software published if you're in scope for JOSS. So pyOpenSci really wants to help the community move forward together. But we want to make sure that we're leveraging wherever we can the existing tools, the existing infrastructure, and the knowledge that all of these amazing communities across our ecosystem have developed over time. We want to build on each other's work. This is the true spirit of both open science and open source. Now, this is just a plot that shows our growth in package reviews over the past years. You can see that when we started, I was kind of working part-time on this, and in 2023, we relaunched peer review thanks to funding from the Sloan Foundation, and you can see the growth in our submissions over time, which has been really awesome. And speaking of, we are always looking for reviewers and editors from the community. We've had over 200 people at this point submit packages and review and serve on the pyOpenSci editorial team. So at the beginning of this talk, I talked about these 4 concepts: cohesion, connection, partnership, inclusion, and usability. And peer review really pulls together all of those themes. By connecting scientists with tools, we're connecting scientists with the things that they need to make their science more open. By creating partnerships, we're learning from other organizations. Inclusion just makes everything better from so many different angles, including usability. If we have more people at the table, we have more eyes on the review, and the review becomes, and that leads to more usable, discoverable software. And this image here is just an image of our editorial team, our growing editorial team. Now, I want to talk next about packaging thorns, because it turns out that packaging is also really hard. I want to tell you again my story. So a couple of years ago, I became a maintainer of a package called Stravalib, and it was really like a mistake. I didn't set out to become a maintainer. That wasn't the goal, but I am a long-time endurance athlete. I love long-distance cycling. I used to be a mountain ultra runner, and my favorite thing to do was play with my data. Like being a data scientist, I was like, data, I want to play with my data. So I started using Stravalib, and then I was like, wow, your docs haven't been rebuilt, and they were on this like Python-hosted platform. I was like, we need to like move this to read the docs, and I can do some CI, and nothing was in CI. There were no tests. So when you submitted a pull request, it was like, I'm going to break like everything in Stravalib, which wasn't a good feeling. And the maintainer just needed to step down. He had been working on it for 10 years, and he was looking for something different. So he gave me the keys. I took the keys, for better or worse. I actually love working on Stravalib. But one of the goals was rebuild the maintainer team. So I got this experience in what does it look like to take a tool that's on the verge of becoming an orphan package, rebuilding the maintainer team, and redoing all of the infrastructure. And in that process, I had to figure out how to create a Python package. And I really didn't know the answer to that question. And I found so many tools out there, and I was overwhelmed, and the documentation was confusing, and it was just hard. It was just hard. So when I go to scientific meetings, I ask 2 questions. I say, 1, what are the tools that you use to create a Python package? And if you look really hard, there's stuff like pandas that maybe isn't a tool that you would use to create a Python package, but this image, you can see build and poetry and conda and setup tools and Sphinx and Twine and GitHub Actions and Mamba and Hatch and Hatchling and read the docs, and I could keep going. but I'm going to stop because there is a lot of tools and I don't have enough breath to talk about all of them. The point being, there's a ton of options out there, and it is not surprising that when I ask scientists, what are your major pain points, they say there's just too many options out there. There's just too much. And it's overwhelming. And it's really hard to figure out what options are the preferred options. What options should we be using to create a Python package? Now, I want to tell you something about options. When you have someone that's newer to an ecosystem, and they have to make decisions repeatedly about tools, that is a recipe for what we like to talk about in the education space of cognitive load. But if we want to say it simply, imagine your brain exploding because there's too many choices to make, or imagine yourself at the grocery store at the end of the day and you're really hungry and you want to make dinner and you're walking down the aisles and you leave the grocery store with lots of chocolate because you're hungry and you just want to eat. Maybe that's just me. Maybe you leave with something else. So the problem there is that when you have too much information, when you're on sensory overload, it's really hard to make good decisions. And if you're talking about technical decisions, there's opportunities here to go down the wrong path, pick the wrong tool, and get stuck. And if you're someone that's newer to this ecosystem, you're not a packaging expert, that's really overwhelming. That's really hard. And we don't want things to be hard for our users, right? We want people to have success. We want them to have early wins. So we have been working on a community-driven packaging guide. The idea behind this guide is 3 things. 1, an overview of the packaging ecosystem. So if you're trying to figure out and navigate the ecosystem, but you're someone that likes to go to the grocery store when you're hungry and you make lots of good decisions, or you just like options, some of us do, that's great. We provide an ecosystem overview for that. But if you're someone that really just wants to get the job done, you just want to make that healthy dinner, you just want to get your Python package, create it, share your code, we have an opinionated tutorial, and we made some decisions around what tools might be good tools. There's no perfect tool for those users. Finally, packaging is hard. I'm going to keep saying that. And so we needed to make sure it was accurate and accessible to beginners. And the accurate part is really, really important. So to do this, we again leveraged the power of community review. And it's the same process in terms of vetting the tools, vetting the content of our guidebook. First, we brought in experts from pyPA, the packaging authority. So we're bridging between the scientific ecosystem and the broader Python ecosystem. We're engaging with tool maintainers of the packaging core tools, with Conda Forge people, with Conda people, with people that are working on PyPy and Warehouse. But we're also bringing in scientists. So when we write a page in the guidebook, I'll start by working with experts. We get a draft out. We have several rounds of review where we bring in people from different parts of the ecosystem to give us feedback. Some pages might have lots of comments. In fact, some of our reviews had hundreds of comments, and some of our reviews were much shorter. And then finally, to make sure that we're getting that beginner-friendly lens, we're getting that usability angle, we have sprints where we say, if you're a new person to packaging and you want to come and learn how to contribute to open source, we'll help you review our tutorials, review our guidebook, let us know how you can come and participate in the process. One of the other challenges around packaging was opinions. A lot of people have opinions about packaging. We had to do a lot of moderation because the problem with opinions is that they push people away. And we love opinions, you can have opinions, but we needed to focus more on people, on tools, on usability, not on tools, on people over tools. And so we encourage people to focus on, we need to get people to that early success with creating a package. We decided to use Hatch. It has a responsive maintainer, user-friendly, adheres to standards, and most importantly, it doesn't lock you in. And this is just an overview of, there is a way to create a package. This is the simplest version of creating a package, pure Python, of course. And you can get a package to PyPy and CondaForge, and there are steps there and tools, and our tutorial walks you through all of these steps. We had a tutorial yesterday where we had most of the room successfully create a Python package, and we had a good-sized room. It was 40 people. So between our tutorials, we've had over 70 people find success with packaging through those events. And then we provide ecosystem overviews. If you want to know the difference between the tools, we've got that information for you too. As of today, we've had over 60 people contribute to our guidebook, which has been amazing. So I want to wrap up. 4 topics: partnership, connection, usability, and inclusion. By partnering, we can leverage each other's work, and we can work together to move the community forward. By connecting, we can make the scientific ecosystem easier to navigate. We can still work independently on our specific goals, but we need to come together and provide a unified space where people can find resources, can find the tools that they need. Usability. This is so important. It's more than just code. There should be a discussion about the people using the code as well, and we need them at the table. And then finally, inclusion. The magic of our community is inclusion. The more voices we have at the table, the better. And we need to actively carve out space for those people to participate. We need to include. I have to just say, as I wrap up here, I'm so grateful for people that are on our advisory council and our editorial team that are leading the way at pyOpenSci. We're going to be doing some more work in more advanced packaging topics and then collaborative Git and GitHub related to contributing to open source. In the fall, we're going to have an online event that is going to be about sprints and training, and please follow us for more information as we figure out, or as we pull that event together. It'll be all online. And if you're interested in getting involved with pyOpenSci, there's lots of ways for you to do that. You can follow the link right here. And I do plan to share this on Zenodo. Finally, we are sprinting this weekend on our packaging guide. If you're interested in joining us, we're translating it to Spanish. If you are Spanish speaking, consider joining us for that. We also have other fun data science types of things. If you're interested in contributing more on like the CI or Python code side of things, I just welcome you to join us. It's beginner friendly. Thank you very much for coming today.
Thank you. Questions?
Thank you, Leah, for an inspiring talk. So you seek to grow this community because a lot of the work that it achieves is human labor, right? Now, does the value of inclusion suffice to help structure the governance structure that you need in order to articulate a large community? Or do you have formal governance structures in place? Do you need formal governance structures in place to manage the growth and garden the growth of the community?
Yeah, that's a good question. And thanks for the easy question at the end of the day. No, I'm just kidding. Yeah, so governance is really important. And so we've been working on developing, we have a handbook, and then our essentially documenting the processes that we follow, and then what that looks like, having a code of conduct in place, like having a code of conduct team. That is not all fleshed out, but we do have all of it online. We have a GitHub repo that's called Handbook. And as we grow, I'm realizing just how critical governance and documentation around how we do things at pyOpenSci is. finally, the other piece is back to the leveraging, which we're leveraging resources from organizations like 2I2C that have great examples of governance. We hope that the work that we do, it's all open, that someone else maybe could leverage that in the future as well. So we're thinking about that as we grow. It's a really good question.
Thanks for the talk, Leah. What is something that you've tried that in retrospect didn't work? Like, we always talk about our successes. What are the landmines that other people don't need to step on?
Yeah. So that's a really great question. The one thing that early on, I wasn't sure if partnerships were going to work until we started working with AstroPi. And what I realized, one of the things that didn't work was when we started talking to Pangeo, Pangeo actually came to us first about the partnership idea before I even got funding. And what didn't work with Pangeo is that they have a lot less structure in terms of how they operate. And so the partnership with them kind of started, and then it wasn't as fruitful because there wasn't leadership and governance like to guide how they made decisions. Whereas when we started working with AstroPi, one of the things that was immediately clear was that they had very clear structure and process for like, this is how we run peer review, and now we're going to switch to working with pyOpenSci, and this is the process. And I was able to like integrate into their process, and they were able to integrate because we had very clear process. So that's where partnership, if you really have like a concrete partnership, that governance piece and that structure, I learned early on that you need to think about that when you're partnering with other communities and what that might look like.
Any more questions? I think we have something on Slack.
Hi, so Henry on Slack asks, are you familiar with Scientific Python? And if so, is it a choice between pyOpenSci and Scientific Python, or do they focus on different things?
Yeah, that's a great question. I'm absolutely familiar with Scientific Python. So I have a list of other guidebooks, and they also have a really great development guide. And I talk with Stefan from Scientific Python. So the big difference is really just the audiences that we're focused on. So we're really coming at it from the long tail of packages, scientists creating smaller tools. When I mean smaller is that not like the NumPy side of things, that long tail of packages, domain-specific packages, whereas Scientific Python has been really focused on the core packages, NumPy, SciPy, and like core AstroPy, Xarray. So I like to see the two communities as being super complementary, but they're kind of coming in from the large core package structure side of things, and we're really focused on beginner-friendly, open science, the smaller packages where people are kind of single maintainer. So it's just different audiences, and then at some point we'll probably meet in the middle, but right now we're kind of at two ends of the spectrum and super complementary. Yeah.
Thank you. Any more questions from the room? Then I would like to thank our speakers again, and then see you at the lightning talks and poster session.